Um, what do you do if your TikTok? What do you do if your teacher says you got to go out and measure the circumference of a tree? God, how do I measure anything? I got a ruler. Circumference, not diameter. Diameter, circumference. Okay, I got this. Got my hat, got my glasses, got my face shield, got my sleeping bag, got my ruler, got my notebook, got my piece of paper, got a pencil. Here's a nice tree. It's a redwood. Gonna start here. One, two, three, 15 feet 8 inches. Let Excel do that for me, or Google. Or you get a string. You know what your wingspan is? Mine's, I measured it. It's something. I measured it. You can use the ruler to measure it. This is exactly 6 feet. I measured it's exactly 6 feet. Six. Well, 12.2. Okay, well, gee, did all the hard work going outside and getting all that hard-won data from nature. Now it's time to do the easy stuff, which is to play around with Excel and get the answers to what we want, which is how much carbon is in those trees. Not carbon dioxide, not wood, not dry biomass, but carbon. We're going to start by doing the reverse by figuring out how much dry biomass is in there, convert that to carbon, and then CO2. Actually, we want CO2 because we want to convert everything to CO2 equivalents. Okay, so open up this here spreadsheet. Make it a little bit bigger for you. Come over here. There we go. So you got to put your name in here. I put my name plus my friend, the doppelganger. I don't really have a friend named doppelganger, but if you have a friend, put their name in there. I did Coast Redwoods. I put in some extra space here in case you wanted to, you did different trees. You could put in different trees. You would record them again down below, but anyway. And then it says, excuse me, from the Jenkins article, page 20, what is beta sub-zero? Well, the Jenkins article, you should have, hopefully your lab instructor has posted it on Canvas. It's also on the lecture Canvas, or should be. And look, here it is. I love this article so much. They did so much wonderful work. This is such an amazing article, so useful. Even though it was published almost 20 years ago, this is useful stuff. Page 20 is down here, and it shows the parameters and equations for estimating total above ground biomass for all hardwood and softwood species in the United States. Not actually true, because if you look at their list of species here, it's not a very long species, and I'm pretty sure there are a lot more species than this, but I suppose many of them are mixed hardwood, or you know what? They don't even have redwood trees here. Oh, so sad. So what are we going to do? We need the species, and then we need these parameters. I might call them coefficients in the lab handout. But the parameters are B sub 0 and B sub 1. And softwoods, which one? We have to choose one for redwoods. And I chose cedar and larch because I know a little bit about cedar wood. When you work it, it's, you know, I don't know. It's about as dense as redwood tree. Redwoods? I don't know. I'm going to have to guess. I'm going to take these here. So beta sub 0 is negative 2.0336, and B1 is 2.2592, which I've put in here. Full disclosure, this is the second time I've cut this video. The first time I did it, I forgot to put the minus sign in it. Rookie mistake. Many of my students have done that. I did it too. And when I did it, I got this enormous number. I'm like, that tree must be 100 cars worth of weight. That seems like a big number. Did I do it wrong? It took me a long time to find that problem, but I found it. I found it. Okay, so we're just going to put these up here because later on we're going to use them in a cell reference in a complicated equation, because that's what you do in Excel. Okay, so edit this file as appropriate if your team measured more than one species of tree. Do that. Insert a new column here and ID the tree species you measured if you measured different species. How would you do that? So, here are the names of the people. You might have another person here. I measured 5 trees. No, I didn't. I'm just pretending I did. My doppelganger measured 10. I'm actually going to do this equation, this calculation for one tree, because you know how to drag equations down and fix them up. I don't need to do that for you. But let's see. What did it say? Insert a new column here and ID the tree species measured. Yeah, if you measure different species, then you might just want to highlight here and insert I guess cells. Oops, I want to shift cells to the right. Boom. And then I could put redwoods here, and my doppelganger could put oaks there, whatever. But I didn't really do that, so I'm not going to do that. Okay, so circumference in centimeters. So I actually measured in feet with my first, I think this measurement is for a 15-foot tree, 15-foot diameter tree, 15 foot 8 inches. I just Googled it, 15 foot 8 inches in centimeters, and I got this number. Later on, by the way, when I was troubleshooting my problem, I suspected that Google gave me the wrong answer. So I Googled centimeters per inch, calculated number of inches, did the conversion, I got the right answer. So, and also I asked myself, 400 centimeters is 4.7 meters. A meter is 3 feet, 12 feet around. Is it 12 feet around? I'm 6 foot, so is it 2 of my huggings? It is. Okay, so I got the circumference, but what I really need is diameter. Do you remember the relationship between circumference to diameter? It's from, what is that class you take? Geometry? Algebra? I don't know. But I remember pi d. For some reason, I remember pi d. But so circumference equals pi times the diameter. So the diameter equals the circumference divided by pi. You could work it out yourself, or you could let Google do it for you. But I put in the equation here. And by the way, do you see this right here? This also, I'm cutting this video, trying to put in pi, couldn't do it. It became very messy, so I'm glad we're not looking at that messy video. But to put in pi, I've never seen anything like this in Excel. You don't just put in, you don't just put in equals pi like you would normally do, like you'd think you'd do, because if you do that, equals pi. So I want pi, but it gives you an error, like what, name what? Turns out you have to put in equals pi and then open and close parentheses. Why? I don't know. But that's how you get 3.141592654. And this is the right number. 152 is the diameter. And now we get to the most wonderful part of this, which is the Jenkins equation. We want to get the above ground dry biomass in kilograms of a tree that's, this big around. It's a redwood tree. How do we do that? Look what Jenkins has done for us. People are so wonderful. They gave this tiny little font down here, the biomass equation. Biomass, dry above ground biomass in kilograms equals EXP times B0 plus B1 times ln DBH. We got B0, we got B1, and now we've got DBH. We just need to put this equation in. What's EXP? You know what EXP is. You used it back in exponential growth. EXP is, you don't know what it is probably, unless you're a lot smarter than I am. It's It's a magic number. It's E something raised to something. Anyway, we don't need to know what it is. We just need to put it in here. And I put it in here for you. Equals EXP time. Okay, let's do it. Equals equals EXP. Why is this shift to the left? It's weird. EXP, what is it? B sub 0, which is over here. B sub 0 negative plus B sub 1. Here's where it gets tricky. I'm going to come back here and refer to this again. Times ln DBH. Times, and I'm going to use parentheses here because I'm very liberal with parentheses to make sure it works. Times ln of the DBH, which is here. Boom. And then I have to close all my parentheses, the purple one, the red one, and the black one. And is that right? B3 plus B4 times that. I think order of operations is correct. Just to make sure, I'll put parentheses around here. Need another one here. Hit enter. 11,000. 11,000. So the Jenkins, if I did this right, the Jenkins formula is saying that the above ground dry biomass of that tree right over there is 11,000 kilograms. Does that make sense? Remember, you always stop and say, does it make sense? I'm a little bit concerned because now, while that number used to be too big because I had the wrong coefficient in there, now it seems too small. Why do I say that? Because a car is about a ton. A ton is 2,000 pounds. A kilogram is 2 pounds. So a car is 2,000 pounds times 2 kilograms per pound. So that's 4,000 kilograms. This number is about 12,000. So that's about 3 cars worth. So I'm getting a figure here that's saying that huge tree there, the dry biomass, when you cut it down and dry everything and weigh it, is only going to be 3 cars worth. So I'm not really confident in this number, but I've troubleshot it. So I'm going to go with it. Seems like too small. If you can find an error in anything I did here, boy, let me know. Diameter. Yeah, that's about 1.5 meters. So the diameter is 1.5 meters. The circumference is almost 5 meters. 5 meters around. Maybe I did something with pi d, but I don't think so. So I don't know. I don't know. You guys check me. I think it's okay. Gonna go with it. Let's do the next one. Actually, you can do the rest by yourself. It's not that hard. What percent of dry biomass is wood? I will help you with this. Let's go to page 24 of Jenkins. Oh, well, the dry biomass, so a tree is not just wood. It contains other stuff too. What does it contain? Well, you can think of it. Bark, other stuff. Page 24 has got it all spelled out for you. Wonderful, wonderful paper. Here it is. These two charts, the one on the left is hardwood. The one on the right is softwood. Conifers are considered softwoods. And look at the chart. This percent of it, whatever that is, which is about 8 minus 2, is wood. Oh, we'll call that 60%. I'll have to change that. Whereas we got branches, roots, bark, and foliage. And roots. Did I say roots? Yeah. So a lot that this shows what the relative parts of trees. It's really cool. So what percent of the dry biomass is wood? Let's call it 60%. You might look at that chart yourself. You might get another number than me because I don't always do things right for sure. Equals 0.6, 60% times this. That's the above ground dry biomass. Makes sense. Wood is 50% carbon. I just looked it up. So that equals 0.5 times this. Boom. And that's about right. Convert it to gram CO2 equivalents. Here's where I'm going to be mean to you guys because you can do it. The way to do it, the information you need is up here. It's kind of described a little bit in the handout. So refer to the instructions for today's lab. So refer to that. And you'll get it to the gram CO2 equivalents. And then you'll convert that to how long you could run. Let's see. I'm going to try to express this. It's expressed in the write-up, but the tree took so much carbon out of the atmosphere. How long would you have to run an air conditioner to put that CO2 back in the atmosphere? Just a way to make this, tangible to you. Okay, so do that for all your trees. One trick is in the Jenkins formula, put in dollar signs for these coefficients here so that when you drag your equation down, the coefficients stay the same. The cell references aren't updated. What did I just do? Dollar. And put in a dollar sign here too. Dollar B, $4. There you go. Got the same number. So if I put in another tree over here, let's see, it was, let's just say it's 36. I get another number there. Okay. So I'm going to delete that. Going to delete this. You do that. You get all your trees. You'll get all the carbon in your trees. You have now done you've calculated carbon sequestration. Please spend some time thinking about these questions here. The reason, why are we doing this? Well, in this class, this is the last lab of the class. In the beginning of this class, we did unit conversion stuff. And you have to do some unit conversion in this exercise. I hope you've gotten better at doing unit conversions. You've learned how to use Excel in this class. This is a good, I've left you to do a lot of the Excel. But more than that, we've talked about the carbon cycle. We've talked about carbon dioxide equivalents. We've talked a little bit about climate change. We've talked about electricity generation. I just kind of wanted to tie it all together in I said this word several times, tangible way, some way that makes sense to you in your own life. You can go outside and you can see a tree or grass, the plants growing. They're part of the equation of life on Earth. They're taking carbon dioxide out of the air and turning it into biomass. You are composed of biomass. These are real things in nature that you're a part of, and now you have the tools to get quantitative about it. And we have to be quantitative about it if we want to address these problems such as climate change and do something about them, which I hope either you will do or at least you'll be appreciative of those people who do. That's what this is all about. Okay, good luck with it. Won't be too hard. Last part of the semester. Take care. Bye-bye.